When we think of a modern battlefield, it's not just about tanks and soldiers anymore. The real fight, the one that matters, is happening in this invisible world of data and networks. So today, we're going to dive into what happens when the very heart of military operations, I'm talking command and control, is built for a war that frankly no longer exists. And we're going to see how it's being completely reinvented from the ground up.
And that really brings us to the biggest question of this whole explainer. Think about that for a second. It's not about protecting a network on a battlefield anymore. The network is the battlefield. It's the primary target, it's the terrain, and everything hangs on how we answer this question.
All right, so let's start with the moment it all goes down. First contact. In conflicts today, that first shot, it's probably not a bullet. It's an electronic attack. It's an immediate, all-out assault on your ability to communicate and see what's happening. The new rules of engagement, well, they're written in code, and the battle is for control of the airwaves themselves. This right here, this is the harsh reality. So forget everything you think you know about having these clear, persistent satellite links. The modern operational environment is what they call contested. That means jamming, low bandwidth, and connections that drop in and out are the new normal. Cyber threats aren't just a possibility, they're an absolute expectation. This isn't a bug, it's a feature of 21st century warfare.
So, you have to ask a really blunt question, but it's the right one. This is pulled directly from a readiness checklist, and it forces us to face a pretty uncomfortable truth. Can your system, the one you rely on right now, actually function the moment the fight starts and the network comes under attack?
Let's get even more specific. Imagine your satellite communications are jammed. You can't reach back to headquarters for information. Now what? Does everyone on your team suddenly have a different, totally fragmented map of the battlefield? Because if the answer is yes, your force has just been blinded and deafened at the absolute worst possible moment.
And that leads us right to the core of the issue. Why are so many of these systems so vulnerable? Well, it really boils down to just one word: centralization. For decades, we've built these systems that rely on a central hub, and that design choice has now become a huge critical liability.
And this slide, wow, it just lays out the mismatch perfectly. On one side, you've got your traditional command and control, built like a hub and spoke. Everything has to go through the center, which creates this one single massive point of failure. And on the other side, you've got modern threats that are designed specifically to take out that center, to deny you spectrum, and to force you into a fight that's so fast, centralized decisions just can't keep up.
So what does all this mean in practice? Well, if you run the numbers and find 8 or more of these kinds of gaps in your system's resilience, you're not just unprepared. You are literally betting the entire mission on having perfect conditions, calm spectrum, and clean infrastructure. And in modern warfare, that's a bet you just can't afford to lose.
Okay, so if the old model is broken, what's the alternative? Let's take a look at one potential solution that's been engineered from the ground up to solve this exact problem. It's a system called CLIC, which stands for Cyberlink Command Center. Now, what's so interesting here is the language they use. It's not just an upgrade, it's a next-generation platform. Its entire design philosophy starts with the assumption that the environment will be hostile. Disconnected, contested, and cyber-threatened. For this system, that's the starting point, not some weird edge case.
And here it is, the fundamental shift. Instead of that old hub-and-spoke model, CLIC uses a decentralized architecture. Think of it like a network of equals. Every single node can talk directly to its peers, and every node is command-capable. There is no central point of failure. And that right there is the key to what's called a distributed decision advantage.
Okay, so decentralized sounds great, but how does it actually work? What are the specific technologies under the hood that make it so tough, so resilient under pressure? Let's take a look inside the network.
First up is something you might actually recognize from the world of cryptocurrency: blockchain. But here, it's got nothing to do with money. It's all about trust. Think of it like a digital ledger that absolutely cannot be altered. Every command gets logged securely, so you always have this tamper-proof record of who did what and when. And you don't need a central server to verify any of it.
Next, you've got what's called a self-healing mesh. This is basically the network's immune system. The nodes can automatically find each other and connect. So if one node gets jammed or goes down, the network doesn't just collapse. No, it dynamically reroutes itself, sending data around the problem area to keep everyone connected. It adapts in real time. It's pretty amazing.
Let's break down a few more of these features, because this is where it gets really practical. Zero trust? That means you can verify that another user is who they say they are, securely without having to check in with a central server.
Geospatial trust mapping, that lets you literally see the health of your network laid out on a map. And ARM compatibility, well, that just means all this powerful software can run on the small, low-power devices you can actually carry with you in the field, not some light version on a bulky server back at headquarters.
Look, tech is only useful if it gives you a real-world advantage, right? So what's the actual payoff of all this resilience and decentralization? It really all comes down to one thing: gaining and maintaining operational momentum.
This phrase, this really captures the whole idea. When your command system is this fast and this resilient, you're no longer just reacting to the enemy or to your own network failures. You are setting the pace. Your decisions land in seconds, and that forces the adversary to react to you. You dictate the rhythm of the fight.
This really paints a clear before and after picture. With a system like this, your teams way out on the edge can act with more autonomy, but they still stay synchronized with the mission. Command doesn't fall apart when you're on the move or under electronic attack. The whole force just becomes more agile, more lethal, because the technology enables it instead of holding it back.
And really, this is the promise. It's not just about better command and control, it's about a chain of command that is fundamentally harder to break. It's a system designed to hold fast when literally everything else is trying to tear it apart.
And the best part? This isn't just some theoretical concept on a whiteboard. They've laid out a really clear, simple path for people to evaluate it. From an initial call to check the fit, to a live demo, and even the option to test it on your own gear. That tells me this is all about practical, real-world application.
So we'll end with this thought. As these networks truly become the new battlegrounds, it's forcing a complete rethink of military strategy. And all the ideas we've explored today, they point to a pretty radical conclusion: that the strongest force might not be the one with the most fortified center, but maybe it's the one that's most effectively decentralized. In the future of warfare, resilience and decentralization might just be two words for the exact same thing.